Hey everybody, it's Mr. Carr again. Today we're going to start off with Unit 8A, an introduction to quadratic functions. So today's goal, we're going to be looking at parts of our quadratic equation. So let's talk about what that is first. A quadratic function is a nonlinear function with symmetry symmetry around a vertical line. Okay, and I kind of made it a little bit longer. So it says here it's a parabola shape. What it looks like is this. This is a parabola shape to it. All right, we can have that, or we can have a parabola that looks like this. Okay, so these are two types of parabolas that we're going to work with in this unit. The axis of symmetry, also known as the line of symmetry, is the vertical line that creates symmetry. Okay, since it's a vertical line, remember vertical lines are always written as x equals some number. Okay, so that's what we're looking at here for an axis or line of symmetry. The vertex is the highest or lowest point of a parabola. Okay, so looking up here, my vertex would be down here and up here. So it just depends on which way it opens. So it's the highest point here, it's the lowest point here. Maximum is the highest value of a function. Okay, so in terms of our quadratics, this is when we get a maximum. So it's actually our vertex right here. The maximum is going to be the highest point of that. So when we talk about a maximum and then also minimum, which is going to be the lowest value of a function. Okay, this happens when my parabola does this. So my vertex right there is my lowest value. So if it opens this way, it has a maximum because it's the highest point it reaches and then it comes back down. This is a lowest point and then it comes back up. So that's a maximum versus minimum. They're both related to the vertex, but just make sure you understand the difference. We also say it a little bit differently because it's a max of y at the x point. It's a minimum of y at the minimum at x. Okay, I'll show that a little bit later on some of the other ones. The last term is intercepts. We can have intercepts are when the function crosses the x-axis or the y-axis. Okay, so if it crosses the x-axis, that's called an x-intercept. If it crosses the y-axis, that's called the y-intercept. Okay, intercept. All right, so those are the two things that we'll be focusing on with those as well. So both x and y intercepts. All right, based on this graph, we're going to identify some of these things. So first thing we can do is probably easiest is to find the vertex. That is the lowest point, which is down here. The point is at 1, -3. So that is my vertex, 1, -3. The axis of symmetry, remember, this is a line, and it's a vertical line. So I'll write that on there too. It's a vertical line for my axis of symmetry. So it does this. I'm going to draw it right here. Notice how it passes through the vertex. So that line is has the equation x equals 1. So as I said earlier, we always write it as x equals, and we're going to put the number here. One thing that's always going to be true, this number will always match up to the x value of a vertex. Axis of symmetry has to pass through the vertex. What is the y-intercept? So I look here, I'm going to see that it crosses at this point here. Y-intercepts, that is the point 0, -1. Y-intercepts are always going to have x equal to 0, no matter what. What are the x-intercepts? I'm going to have to kind of estimate this a little bit because you see it crosses here and actually also crosses here. Okay, So I'm going to estimate it. So at the very least, we can say this. They are between -1 and 0, like between x equals -1 and x equals 0. It's also between x equals 2 and 3. Okay, so I have a range there that's pretty easy. I know it's in between 0 and 1 in the x direction, and it's between 2 and 3. I'm sorry, 2 and 3 here. I can probably be a little bit closer with my guess. If I were to estimate this, I would say that's a little bit past a little bit past 0. I don't know, probably not quite a quarter of the way. So let's say this. Let's say one of them is going to be at -0.2 and then 0. The other point looks to be about 2.2 and 0. One thing I want to mention here, if I have an x-intercept, y is always equal to 0. Okay, so it kind of flip-flops it. Does this quadratic have a maximum or minimum? As the least amount of answer possible, this has a minimum. Okay, based on the fact that this goes down, stops here, and then comes back up. That's the lowest point. Remember, minimum is the lowest. So we can also say it this way. It has a minimum of -3 at x equals 1. That's what I was saying about minimum of y at x. Okay, so that's another way of describing it. But at the very, very minimum, just say minimum. All right. Two forms of quadratics that we're going to look at in this unit. The first one is called the standard form. It looks like this. Y equals ax squared plus bx plus c. The other part of a quadratic is it has this right here. It has to be raised to the second power. Okay. So as long as you have a term that's raised to the second power, we have a quadratic function. So if I look at these options here, x squared makes it quadratic. Okay. It says linear or quadratic because when we look at the next one, I don't have an x squared. I just have x to the first. When we have x to the first, that's a linear function. Okay, here we have x squared, so that's quadratic. And then again, x squared, so that's quadratic. From there, I want to identify a, b, and c. These are my what's called parameters. Okay, these numbers will actually change the graph of how it looks, but that's something we'll talk about in a future one. Notice that a is always attached to the x squared, b is always attached to the x, and then c is off by itself. So when we look at this one, a here, if there's no number there, it's actually assumed to be a 1. So a is 1, b is 4, c is 7. I'm not going to worry about these because it's a linear function, not quadratic. Here, a is a 1 again. I don't have an x term. So b is actually 0 and c is a -10. In my last example, a is 8. 7x means that b is 7, but then I don't have a c term, so that's going to be 0 there. Okay. Vertex form of a quadratic looks a little bit different. Vertex form follows this pattern. A multiplied by x minus h squared plus k. Okay. So what we have is we have this kind of binomial that's in parentheses squared, the a value in front and the k at the end. So if I look at that one, I have squared again, no squared, and then squared. So we have quadratic, linear, and quadratic. Okay. So if I look at these parameters, a, h, and k, look at their positions. A is in front of the parentheses squared, h is on the inside. It's also minus h. So that's going to be important when we do that. And then a plus k at the end. So for the first one, I've got 4 in the front, so that's my a. -7 inside there, we're actually going to do this. H is going to be a +7. We're going to do the opposite value. Because if I say x minus h and I say x minus 7, then the actual h value is 7. And k is the same as the 10 on the outside. Here, we have a 1 in front, so that's a 1 for a +1 on the inside, so h is a -1 with no k at the end, so that's a 0. This is linear, so we're going to skip that one. And the last one, we got a -3 for a. We have even though I don't have parentheses, technically speaking, this right here is my set of parentheses. This is the same as if I did this. X minus 0 squared plus 5. So that means my H value is 0 and my K value is 5. So these are just our two equations that we're going to focus on, and this is going to be a lot of what we do in the rest of this unit. So that's it for day one. Again, these are just parts of quadratics, looking at these different types of vocab terms and how they apply on the graph right there. And also we're going to look at a little bit about the different types of ways we can write our quadratic function, standard form and vertex form. All right, that's it today. Take care.